So now we have a trapezoidal rule that we're trying to approximate the value of a given integral by using the trapezoidal rule with n is equal to 4. So we're going to use this formula. The integral from a to b of f of x dx is equal to delta x over 2 times f of x0 plus 2f of x1 plus 2f of x2, and going all the way to finish this out. So we can first notice that in our problem, our a is equal to 0, our b is equal to 2, and we can find our delta x using the formula that delta x is equal to b minus a, which would be 2 minus 0, over n, which is 4. So that makes 2 minus 0 is 2, over 4 is 1/2. So our delta x is going to be 1/2. So we can rewrite our problem as the integral from 0 to 2 of 5x squared dx. That would be equal to, the numerator is 1/2, plugging that in for delta x, over 2, times, now we need f of x0, so we're dividing a to b into n subintervals. So if we're going from 0 to 2 in 4 subintervals, we would need x0 to be 0, and then xn, which is x to 4, to be 2. So breaking that up would be, for 4 subintervals, we would need x1 to be equal to 0.5, x2 to be equal to 1, and x3 to be equal to 1.5 to evenly break up from x0 to x4. So plugging that in for f0, that would be f of 0 is 5 times 0 squared, plus 2 times f of x1 would be plugging in 0.5, so that would be times 5 times 0.5 squared, plus 2 times 5 times 1 squared, plus we have one more with a 2 coefficient, times 5 times 1.5 squared, and then the last term does not have a 2 coefficient in front of it, so it would be just times 5 plus 5 times 2 squared. So simplifying this would be 1/2 divided by 2, flip the denominator to make that 1/2 times 1/2, which is 1/4, times 5 times 0 squared would be go to 0. Then we have 2 times 5, which is 10, times 0.5 squared, which is 0.5 squared, which is 0.25, times 10 is 2.5, plus 2 times 5 times 1 squared would be 10, plus 1.5 squared is 2.25, times 10 is 22.5, plus 5 times 2 squared would be 20. So this gives us 2.5 plus 10 plus 22.5 plus 20 is 55, but then we need to divide that by 4, and that gives us 13.75. And I'll do part B in a second video.